Hello everyone, so this is Mohammed from PYCAD. So in this video, I'll be showing you how you can do medical imaging classification using the pre-trained model that we know like VGG16, Inception, Exception, and all these models. But I will show you how you can exactly change your parameters to get the best results with these models. So let's get started. So for the purpose of this video, we'll use this dataset from Kaggle, which represents a classification for 8 types of cancers. So if you want to use it, you can just download it here by creating an account, and then you can download it and use it. Otherwise, you can use any other type of classification data. So for me, like this dataset, like have 8 classes, and each class has 500 files. So I took them and I split them for tests and for training. So for tests, I have 50 images per class, and the remaining images are for training. So 450 images per class here. So here we have 8 classes, the same thing here. Okay, and this is the models that we will discuss after. But now let's start talking about the config file, for example, because here we have the config file utils, we have the train and test. For this video, we are not going to do the training part because I think most of us know how to do the training with TensorFlow, but the scripts will, of course, will be provided in the GitHub, so you can just check it and use it if you want to do the training with the same way that I did. But I will, although I will really explain how the script is working. But before that, let's talk a little bit about the config file. So the first thing that we are presenting here, which are the data paths. The first path is for the annotation, which is this one, which represents the classes that we have for our model. But here, if you, for example, you don't know how to create this annotation, you have only the folders of the files here, then you can use this function from in utils. I have already presented it. Here you can use it, and it will create the annotation file from the part of your training or testing images, and you can just give it here as parameter, and it will create the annotation file with the classes. You can find it here in the utils, which is already in the folder utils here. Okay, and now where is the config? Yes, this is the config. So you have here the annotation.txt file for the classes, for the annotation, and you have these 2 folders, one for training and one for testing. And after that, for the config here, you can choose the dimensions of the input image. So like it is like 224 by 224, for example, for the VGG 16, or for example, for the exception, you can use for the 299 by 299. Like you can use something else, but preferably like it's recommended by the documentation is that if you use the BGG16, for example, preferably you can take the 224 by 224 dimensions because it works well for this architecture. And if you are using, for example, exception or inception v3 or something, you can take the 299 by 299. Okay, so here you can choose the dimension, here the number of epochs, here when we are talking about the training, and here for the learning rate as well. And the last one here is the head of your training. So here you choose the pre-trained model that you want to use. So it can be for the function that I will discuss in the train script. You can use either exception VGG16, inception v3, or densenet 121. So here you choose directly, like it is a string, you just copy and paste one of these and it will be imported directly in the training script. Here, as I told you, you can just, this is the config file, you can choose the dimensions. So for example, if you choose exception, so preferably, so you need to choose the 299 by 299. You cannot use the exception with the 224. But I am not saying that you cannot, but preferably if you train an exception model, you should take the input size as 299. If you train a VG16 model, for example, you choose the 224 for the input. Okay, now let's move to the training script. Let's save this one for example, and now let's go to the training script. Now here, as I told you, I will not go for all the training process, but I will explain how it works. So if you want to use the same model, the same script for training your models, then it will be easier. So the first thing here, we have the this function, which is return dataset. So it will return it will take directly the input directory for the training, because the testing directory will leave it for evaluation. So we will not use it either for training or for the validation, but you take the training images here to the input, and it will create the train dataset and the testing or the validation dataset here with the split of 20% here, 0.2 for the validation split. And of course, for the label mode, we are going to take it like categorical, like one hot map, and like for yes, for the same thing for the training and for the validation. And after that, here, if we go to how to choose the model, so we will talk about how to choose the pre-trained model and how to add the other part for the classification. So of course, when we choose the pre-trained model, we don't need to include the top, which is for the classification, because we want to use it for another purpose instead of using it for ImageNet, for example, dataset or something. But we do include the weights that has been trained one training the model, for example, exception on ImageNet. We do include them, but we don't include the top, which is the last layer for the classification. So this is how to choose because you remember in the config file here we choose exception VG16 inception or DenseNet 122. If you want to add more, of course, you can add them here in this function. But for me, I just wanted to take only these four for the testing purposes. But if you want to add more, then you can do that. But here you can see that the first thing, like we are choosing the head, so it should be one of these four. And after that, there is this part, which is the most important thing of this video. So all this video is talking about this part. And after that, we have this creation of, like, we added a global max, well, like we added the global average pooling layer, then we added a fully connected layer, and after that we added the predictions, which is like the final fully connected layer, which has the neurons, number of neurons as the same number of classes, with a activation of softmax, of course, so that we can predict the probability of each class. But let's go back a little bit here. You see here that if freeze, this is one of the parameters of this function that I am adding to this return model function. So if it is set as true, so we are freezing the pre-trained layers. So what does this mean? So when we import this model, which is like, for example, exception, and we are not including the top, of course, but we are taking the weight that has been trained on ImageNet, for example. So when we are doing this, and now we have a model, we have the architecture plus the weights. Instead of having random weights, we are having the weights from ImageNet. But we are freezing these weights. So if, for example, our model has been trained to detect the circles, rectangles, or any kind of these shapes, because we have a lot of convolutions happening there, because these are big architectures, so we are having a lot of features inside these architectures. But we can either choose to not change them. So for example, if you load your weights here, you can either choose to not touch them. So if, for example, one weight is like 0.01, for example, or a matrix, so you cannot touch it, you can leave them like that. The only thing that will be changed is the classification layer, or if you add, for example, these layers, so only these parts that will be trained, not this one, because this is the output of the pre-trained model, but these here that will be retrained. But the idea here when we do this, meaning that we are trusting the weight that has been used for training ImageNet, for training exception or any one of these models on the ImageNet dataset. But the idea here it is not always the case, because sometimes it can work, but sometimes it cannot work, especially for medical imaging, because the types that we have in medical imaging are not the same as the images that we have in ImageNet, for example. We don't have like normal people, like tables or something like that, but we have like specific part of the body, or we have a cancer cell or something like that. That is not included in the ImageNet dataset. So the question here is, it good to leave these weights without touching them, or preferably we took the architecture, we took the weights, but we don't freeze them. We don't put them as constant value, but we retrain them. So if, for example, we do a one forward propagation and we find that the output is not good, for example, and when we do the back propagation, so here we can choose or to either retrain the model retrain the weights, or leave them as constant. When we say constant, so we just set the learning rates as 1, so we don't change the gradient descent, for example, value or something like that. But for this purpose, when I trained the models multiple times for multiple data sets, I found that the best thing to do in medical imaging, like when you do the classification, and I tested that with all these models. You can test it with more if you want. Here I am showing only for 2 models, but if you want, you can choose any model you want. And for me, for these 4 models, I found the same thing. Like, you see that if you don't freeze your models and you leave them like trainable, so here either you put it as true, but by default it is true. So you just put this freeze here that I am putting in this function like true, and no, sorry, like false. So if it is false here, then this part will not be run, meaning that the trainable layers will be always true. We will not put them as false, meaning that the architecture will be retrained from zero. Now, I'm not saying from zero, but you took the pre-trained weights, but this weight will be retrainable. So if you want to update your weights, so also this weight will be updated. And this is the best thing that I found. So when you do the classification, or you do the training, you will notice that it will be like a big difference between freezing the weight or not freezing the weight, for medical imaging especially. I found that it works even for other tasks, but for medical imaging, like, it is the best thing to do, like retraining the models and not freezing the weights, like not freezing the weight or not freezing the layers, like for the head, which is for backbone architecture here. For example, if it is exception VGG16 or any one of these 4, or others if you want. And yeah, this is for the freezing the layers. And now here, as I told you, we are like applying the average max pooling. We are adding this sigmoid, the fully connected layer with the sigmoid activation. And I noticed another thing here. So this layer, sometimes it is affecting the results. So if you need my recommendation, for example, I would I'm sorry, I think that the recording has stopped in some point, but let me just complete what I was saying here. So for this part, I think we have already spoke about it, like freezing the pre-trained weights. But now let's talk about this part here, which is adding an additional fully connected layer, or not adding it. So as I told you, I saw that, for example, if you need my recommendation, I would preferably not add it, but in some cases, and you will see in some points, it may adding this, but not all the time. You should always test with it and without it. But most of the time, you will get better results without this additional fully connected layer. Now, let me just go to the training part. So for the training, uh, as I told you, I will not launch any training here, but I will give you the script if you want to do that. But for for this training, I took the gradient descent, and from this I took the SGD. But you see here in like a newer TensorFlow version, you cannot import the optimizer directly from Keras. Like, you cannot import, sorry, SGD directly from optimizer, but you need to import gradient descent, and from gradient descent you can import the SGD. as I am doing here. Because if you don't do it this way, you will get errors because it won't work. But and the same thing for the learning grade, I am adding it from the config file that I gave it here, like it is 0.01. If you for me it was the best one, but if you see that it is not working well for you, then you can decrease it into 0.001 or something like that. But for me, this value is the best for this task. And of course I am saving the best ways here in the callbacks, because I need always to check my model in the validation dataset that we split when creating the dataset. But here I am doing that when on the validation accuracy. So whenever we have the best value of validation accuracy, we save those weights before getting overfitting or something. And of course, here we are launching the training, but for me, I am not going to launch it because we have already the models here. I trained for this video, I will show you here we have two models, but I trained four of them. And you can do the same if you want to add more models, then you can just add them here in this function and call them here in the config file and change the head here. And yeah, now let's after we train the models, now let's go to talk about how to evaluate the model, which is the purpose of this video. Now we have this test script that you can use for your models. So when you will get, I will give you the link to GitHub for this scripts. And the first function that you will have here is for the returning the test datasets, which is the same as we did for the validation and for the testing datasets. So we are reading the images here in directory. It will be from this test script, the test folder, not from the training folder. And we are applying the same thing. We are fixing the whole seed, the same seed, and we are using the image size the same as we did for the training, and the batch size, for example, 16. And for the label mode, we are taking categorical, like one hot format, and we are returning this test dataset. Then we have two functions for the predictions. We have this first function that I created for predicting one image. So it will directly took the image, do the pre-process, and for example, here it will return two variables or two values. The first one is the predicted class, which has been took from this string list. And then we have the probability of this class. So this is the function to predict the probability and the class of one image. And then we have this evaluate model, which is for evaluating the model on a whole directory, which is using directly. Actually, it is based on the model that evaluates from Keras. So we are just taking the model. So and after that we are returning the dataset using the function return dataset test dataset after preprocess, of course. And then we are loading the model and launching the evaluation. And we are returning two scores: score 0, which is the loss, and score 1, which is the accuracy. So these are the functions that will be used. Now let me just do some testings in few models that we have trained. I have trained before, but of course, if you want to do the same, you can directly use the dataset. I will give you the link to the dataset to Kaggle. If you are interested about the same dataset, then you can use it. Otherwise, you can use your own dataset and the same training code and testing code. So here we are giving two variables. The first one is the path to the model, which will be changed for each test run that we'll use. The second thing will be the path to the image. For me, for example, I took this random image from the testing dataset, and this is the class and this is the image. So we'll predict this, for example, for this image, we'll predict the class plus the accuracy. And then we will launch the evaluation for the whole testing dataset, and we will print the loss and the accuracy for all the directory. So for example, let's start by this VG16 model. So since we said that for the input size here, we are for the input size of the image, we are taking it. So let's go here, return image. Yeah. For the inputs dimensions, we are taking them from the config file, always the same thing as we were doing for the training. So we need to go here and make sure that since we are using the VG16, we make sure that we are giving the input dimensions into 224. Otherwise, it won't work because the model has been trained directly on the 224. So it is expecting an input of 224 by 224 by 3. Otherwise, it won't work. So here for the testing, let's go here. Let me start by this model, for example, rename. I'm a lazy man, so I'm just copying the name. And yeah, so yeah, for the first model will be the VG16, like freeze meaning that when we have frozen the weights, and you need to know that all the models has been trained on the same parameters, like the same optimizer, the same loss function, the same learning rate, the same number of epochs, the same number of batch size, everything the same. The only thing that has been changed in is freezing the weights or unfreezing the weights. The second thing is like adding a additional fully connected layer or not adding it. These are the only changes that we had. Otherwise, everything is the same. So here let's run the testing. For example, the first cycle with this model freeze when we have frozen the weights. And so we will run the prediction on one image, which is this one, and we will run the evaluation for the whole direction. So here I will run the code. And yeah, so here, for example, it's predicted for this image, it's predicted like it is a class polyps with 100% of probability. And in reality, it is not true because this image is belonging to the class like dyed lifted polyps, which is not polyps because there are two different classes. We have the polyps and we have the dyed lifted polyps. So which means that the model is wrong and 100% of probability wrong. And after that, we have when we run the evaluation, we have the loss, which is like very big value, and then we have the accuracy, which is for 55% for the whole direction. And now you see that the model is not performing well for this task, which is like we are using VG16, which is a big architecture, but it is not predicting the best values. Now let's try with another thing, which is without freezing the weights. So I have already trained a model for that, but before that, let me just show you the freezed weights when we took this model after freezing the weights, but when we added additional fully connected layer. So to do that, let me just add here x meaning that this model has been trained with here has been trained with this additional fully connected layer. So to test it, let me just run it here. We will not change the dimensions because they are the same. Only the architecture has been changed, but inside, which is not something that we change from the outside. But yeah, this is, for example, you see that it is always predicting this image into polyps, and now it is with 38% of the probability, which is always wrong. And for the loss and for the accuracy for the whole directory, you see that the loss has been decreased better than 222, but for the accuracy, it decreased as well. So we had 55%, now we have 51%, which is always not good for this type of tasks. Now let's go but you see that when we added the fully connected layer, it's affected the accuracy and it went from 55 to 51. But now let's go and see when we retrain the model, and we'll do the same thing with the fully connected layer and without the fully connected layer. Now let me just copy this. So yeah, let's do the same here for one image and for the whole direction. Just loading the model. Yeah. So now when we have done that, you see that for the image, it is like predicting the exact class with 99% of the probability. So you see, 99% of the probability, like it is pretty sure, and the class is dyed lifted polyps, which is the exact name of which is the exact class of this image. So it is predicting correctly the image. Plus, for the loss, it is 0.42 for the whole directory, and for the accuracy, it is like 87% for this image. But you see here when this not for the image, sorry, but it is for the whole directory, testing directory here, because when we run the evaluate model function, it is evaluating on the whole directory or the whole test directory. But you see, this function here is when adding the fully connected layer. These results are with this. If, for example, I take this off and run the inference again, you will see that in this case, precisely, for example, it won't give the best results. It is this always the same, of course, it is always the best. But for example, here you see always the same class, the good probability. But the accuracy here, you see that it decreased a little bit when we deleted the additional fully connected layer. So you see, before that, when we didn't use the fully connected layer, when we have frozen the weights, it was better when deleting the fully connected layer. But now, when we didn't freeze the weights for the pre-trained model, it is doing well when freezing, when adding the fully connected layer, because here it is like 87.7, but here it is 87.0. This is not a big difference, but it is always different that we can discuss. So this is what I wanted to explain in this video, especially in the medical imaging. You see that when you don't freeze the weights for the pre-trained model, it may give better results. I tested it on 2 or 3 data sets, and it was always giving the best thing. And even I tried this and tested it on data set that is not belonging to medical imaging, and it did well as well. So if I may recommend you, especially for medical imaging, which is the purpose of this video, I may recommend you doing this training the same as I did, without freezing the weights for the pre-trained model. And if you want to add an additional fully connected layer, then you need to test with it and without it. So I hope that this video was helpful. If you have any questions about this, please leave them at the comments. Don't forget to thumbs up and subscribe to the channel so that you can help us to do more videos. And see you in the next video. Bye bye.